China, hailed as the infrastructure maniac. Former US President Trump once openly declared that America would never be able to compete with China. I love China. People say, "Oh, you don't like China." No, I love them. But their leaders are much smarter than our leaders, and we can't sustain ourselves. China, you go there now, roads, bridges, schools, you've never seen anything like it. They have bridges that make the George Washington Bridge look like small potatoes, and they are all over the place. Does reality truly align with the president's description? The truth emerges as we dive deeper. What you're witnessing is China's monumental cross-sea megastructure, the Shenzhen-Zhongshan Link, an engineering colossus spanning turbulent waters. It serves as a core transportation hub project in the Guangdong-HK-Macau Greater Bay Area. Stretching 24 kilometers in total, this project is an integrated cross-sea engineering feat, combining bridges, islands, tunnels, and underwater interchanges, including an undersea tunnel that spans approximately 6.8 kilometers. In this tunnel, engineers embedded 23,000 fiber optic sensors within the immersed tubes, allowing the concrete to sense stress changes in real time, much like human nerves. This technology is 40% more sensitive than its Western counterparts, prompting even the journal Nature to exclaim, "The Chinese have taught concrete how to think." Next, we will examine in detail how Chinese engineers built this undersea tunnel. This tunnel, 6.8 kilometers long, is designed with 8 lanes in each direction, 2 more lanes than the Hong Kong-Zhuhai-Macau tunnel. It is composed of 32 giant immersed tubes and a final joint, buried more than 40 meters beneath the sea. When Dutch immersed tube specialists declared an 8-lane bidirectional configuration impossible, Chinese engineers staged a subsea engineering marvel in the Pearl River estuary, deploying an innovative steel-concrete sandwich composite structure that defied Western engineering conventions. Traditional immersed tube tunnels typically employ cast-in-place reinforced concrete, a process that is both labor-intensive and time-consuming. For the Shenzhen-Zhongshan Link's undersea tunnel, engineers adopted a steel shell design. However, the 8-lane configuration significantly widens the tube structure, with each additional lane increasing hydrostatic pressure by 27%, approximately 20,000 metric tons per lane. This equates to bearing the combined weight of 15,000 sedans. Compounding this challenge, the overhead navigation channel accommodates 10,000-ton cargo vessels. The dual pressure from hydrostatic forces and shipping loads creates a structural conundrum akin to crushing forces on a beverage can, potentially causing tunnel deformation. After thorough research and verification, Chinese engineers decided to use a steel shell concrete structure. In essence, the process begins with fabricating the tube steel shell, followed by concrete infilling, a composite construction method that significantly enhances compressive strength while eliminating traditional rebar tying. This innovative hybrid structure achieves a 400% increase in flexural rigidity, a breakthrough so transformative that the ASCE has incorporated it into their latest design specifications. The immersed tube is manufactured in an automated facility where steel plates are precision cut into various profiles, then robotically welded. Intelligent welding robotic arms achieve 0.02 mm seam alignment accuracy, the error being only a third of a human hair's thickness. Certification testing by Germany's TV Rheinland confirms that the weld quality exceeds DIN 6700 standards by 22%. Due to their enormous size, each tube is divided into 22 segments. After each segment is completed, a gantry crane assembles them, followed by final assembly work by the crew. Besides the robust and watertight exterior, ensuring that the tube remains corrosion-free for 100 years underwater is key. After the steel shell is completed, its surface is sprayed with 5 layers of anti-corrosion coating with a molecular structure that mimics shark skin, leaving no foothold for algae or bacteria. Each tube is then equipped with 552 sacrificial anodes, ensuring that under their protection, the tube can be safely used for a century. Next, the tube is transported to another facility for the final concrete pouring. The underwater immersed tubes of the Shenzhen-Zhongshan Bridge are designed with a steel shell concrete structure. Once the steel shell is completed, its inner chamber is filled with concrete. The total volume of concrete for 32 tubes exceeds 1 million cubic meters. At this point, manual labor could no longer keep pace, necessitating the use of intelligent concrete pouring robots. These robots autonomously move along predetermined routes on the tube's top slab, automatically detect and drill holes, and perform the pouring operation entirely on their own. Using 1,200 sensors to continuously regulate the concrete's flow rate, these smart robots compressed a process that traditionally took 90 days into just 28 days. Even more astonishing is the zero manual vibration technique. Self-compacting concrete flows like melted dark chocolate into every crevice with nanometer-level precision, comparable to the intricate distribution of capillaries in the human body. To formulate the optimal composition ratio, engineers dedicated 3 years to systematic experimentation, even building a full-scale tube module to simulate the tube's ability to withstand more than 1,000 typhoons and resist a level 9 earthquake, as well as a scenario in which sea levels rise by 3 meters by 2075. This die before rebirth Eastern philosophy reduced the project risk by 83%. These simulation tests effectively validated the reliability of using this specialized concrete in the immersed tubes. Although this concrete's strength and flowability meet the requirements for casting the tubes, once it leaves the batching plant, it must be poured within 90 minutes. This critical requirement led to the creation of an intelligent manufacturing facility capable of casting 1 tube section per month, earning its reputation as the Smart Dream Factory for immersed tube prefabrication. A complete steel shell immersed tube weighs as much as 80,000 tons. Moving it a mere 200 meters to the departure area is no small feat given its massive weight. With 200 transport vehicles and over 1,000 steel wheels, the 80,000-ton tube was slowly moved and transferred in just 4 hours, a task that used to take 7 days for a tube of similar mass. Before a tube can be brought in or out, workers must conduct final inspections. Using millimeter precision, non-destructive testing equipment, the density of the concrete can be assessed without damaging the steel shell. Once approved, the tube is fitted with a ballast water tank and steel sealing doors, then maneuvered by buoyancy into a deep-water dock. Next, it is ready for installation. Now that the Shenzhen-Zhongshan Bridge is fully operational, a brand new landmark mega-project spans the Pearl River estuary. When the first car's headlights pierced the darkness of the undersea tunnel, it was not just the rebirth of a transportation artery but an epic dialogue between humanity and the ocean. Chief Engineer Song Shenyu told reporters, "We spent 16 years turning a wild idea on paper into a routine reality that millions cross every day. Our project is located right at the geometric center of the Guangdong-Hong Kong-Macau Greater Bay Area. The construction conditions around it are exceptionally complex. Flood prevention and tidal response are also quite sensitive. We conducted 52 related topic validations, among them, navigation carried out 19 parallel certification tasks. If the Hong Kong-Zhuhai-Macau Bridge is a maritime link binding Guangdong, Hong Kong, and Macau together, then the Shenzhen-Zhongshan Bridge is the key to opening up the golden inner bay of the Pearl River estuary, further boosting economic development in the Greater Bay Area. With its global leading scale, complexity, and speed, Chinese infrastructure has become a shining, national card that captures the world's attention. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments. Don't forget to subscribe and hit the notification bell. See you in the next video.